Hello guys, this is Roberto from Developer. Welcome to the very first video of a series of videos that I'll be releasing to accompany the different resources and articles that I'm releasing at the website. This first video is to complement the Draft Your Circuit block diagram resource and the When You Start a New Journey, Don't Forget Your Map article. In this video, I will go through the different steps that you can see in the worksheet, and I will design and draft the block diagram from a previous project I did that you can see on the Don't Forget Your Map article. Okay, so let's get started. If we go to step 1, we need to first write a list of our circuit elements and sub-elements. In this initial step, it is assumed that you already know what you're doing. You don't need to already have your circuit, schematic, or any technical details, but you need to have a clear view of your system and what you're doing. And one way to achieve this is by using specifications and requirements for the project. So for example, this is my previous project I did for university, and I will jump into the requirements and specifications section. Okay, here you go. As you can see, it's not very complex, objective, specifications, requirements, but just having this is actually enough to get us started. So let's go through it. In objectives, this actually a better word will be function. Is basically a description of what the device does. So what does the mini electronic congas do? It's a standalone device capable of reproducing, adjusting gain, and mixed digital audio files when the user hits one of the drums with the least latency possible and maximum battery life, and able to recharge it. Also make it the smallest size possible to increase portability. So just by reading this, we already have mentioned a couple of elements that our circuit should have. So what we have to do, write a list. So take a pen and paper, open a text editor, whatever. So let's get with that. As it says on our worksheet, a good way to start is to divide it in circuit types. So let's do that first. We number these. So analog, just analog, power regulators, power sources, digital connectors, other elements just in case. So very well, we have here our initial structure. So we go back to our requirements and specifications, and we start reading again. So standalone device capable of reproducing, adjusting gain, and mixed digital audio files. So in order to do all these three things, you need digital processing of files. Therefore, you need an MCU or CPU. In this case, we're going to choose an MCU. So in digital, we can add okay, well, just do it like this: digital MCU. Okay, we keep reading. When the user hits one of the drums with the least latency possible and maximum battery. So when the user hits one of the drums, so over here we're talking about some component that will interface the outside world with our system. this component, we can call it a sensor. So in other elements, we're gonna add a we'll call it pressure sensor. Yeah, pressure sensors. Okay, and we keep reading. Battery life, right? So our power source is actually a battery. Battery, able to recharge it. So we need to recharge our battery. So we're gonna have a charging circuit. Okay. So we already have a couple of elements that we will use later to add in our block diagram. So now let's get into the specifications. Right, so the first two are actually more physical than electronic. Number 3, it's talking about battery again. Battery should be able to be recharged via USB or solar panel. So in order to connect a USB to the board, we need a USB connector. So let's add that to the connectors. USB. The same for the solar. So we just say we have a solar jack. We can call it like that. What else? The device should have the highest audio quality possible. So we need to convert our digital samples into an analog waveform. In order to do that, we use a digital to analog converter. So that's another element that will be included in the MCU, but because we want the highest audio quality possible, we're gonna choose an external DAC. So we can choose one with really high quality. So what else? The device should have an audio output that can be connected to an external mixer or amplifier. Okay, so that's another connector. So we have audio connector. The device should have an on-off switch. So on-off switch, because that's our connector as well. On-off switch. Well, the MCU needs to be programmed, so one of the connectors is actually the MCU programmer. And okay, we can keep reading. There must be a light that indicates the device is on and another one to indicate that it's charging. So what do we have here? We have, actually we can add a different category and we call it, oh man, this is terrible. So let's just put it on analog. On LED and charging LED. And then let's think about it. Okay, so we have external sensors, pressure sensors. In order to connect that to the board, we need actually more connectors, right? Sensors, connectors. Then to interface the sensors to the MCU or the rest of the circuit, we need some sort of interface circuit. So we just add here buffer slash amp circuit or signal conditioning. Okay. Anything else we're missing? Maybe we can add a sub-element from the MCU. The crystal oscillator. That's a very important part we cannot miss. And finally, I think we got it all. Actually, we can add another analog circuit, which is a low pass filter for DAC, because we want really good audio quality and we want to filter out any high frequencies that might be coming from the DAC. Okay, that's step one done. We go back to our list. Second step, draw and position your circuit elements and sub-elements. Okay, so if this is your very first time and you don't know how to use a diagram software, I recommend just take a pen and paper, because it's so much easier to draw there. You can draw as you like, you can connect, you can throw it. This diagram software, they take a bit of time to get used to it, so if this is your very first time, maybe just take a pen and paper and go for it. So that said, I use Visio. So let's open a new Visio window. Microsoft Visio. It's very good for block diagrams. However, you have to pay for it. Just a blank drawing. Yeah. Okay. So first thing to do for me, let's put this in landscape and let's make it an A3 sheet. This time when you print it out, this way when you print it out, you actually get to see exactly the same thing you're seeing in the screen. Very well. So we go at step 2.1. Draw a rectangular area to set the limits of your circuit. Fine. So over here, think about the PCB actually. Like, I know this is an abstract diagram, but you need to think like this is also gonna contribute to the PCB design. So we look for a rectangle, drop that here, we make it big, and we need to think this is our actual PCB, this is our board. Let's make it green so it looks even more like a PCB. Okay. Then what's the next step? On the edges, draw the connectors. Okay, so mostly you will have your connectors on the edge of the PCB. This will benefit EMC testing, electromagnetic compliance. So normally you will have the connectors on the edges. So for example, we make another figure here. I like to put it yellow for the connectors, and we can call that so what's the name of our connectors? Audio connector. Let's call it audio connector. We drop it here. That's our first connector. Then we keep placing connectors along the board. USB connector. And so on. Oh, just remember, we missed one digital circuit, and that's memory. One of our requirements was to store data, so we need sort of memory device. And because the user needs to be able to change the memory, that memory is going to be an SD card. Okay, go back to our design. Okay, because this is just going to make the video really long, I'm just gonna go and jump through the different steps. I won't be placing every square and writing every label on it. Okay, so after we've placed all our connectors, our device, our board should look like this. So in here we have our board with all connectors. See, USB, we have USB here, solar jack is a PV, photovoltaic connector. Then the audio connector is over here. Sensor 1 connector, sensor 2 connector, and so on. SD card, and switch connector and battery connector. Forgot to add that one too. Battery connector. Very well. Okay. So after we have all our connector blocks, we go to the next step. What's the next step? Place the MCU or main IC in the middle. So I like to start with the main integrated circuit. In this case is the microcontroller. So again, we take another block, we throw it there, give it a name, and we give it a color. So I like to have digital ICs, one color, and then analog circuits or analog ICs and different color. This way you can differentiate between one or the other. And then I just have to start throwing other circuits. What do you do with that? So you take your list, and each of the circuits is actually one box. So you're gonna throw another box, and you're gonna call it battery charging, for example, because this is not a digital IC. I will put different color, and you repeat the process with all the other elements. So I'm gonna jump again into the next step, and this is how it should look like. So here I have all my elements. Some of them even resemble the circuit equivalents. For example, the buffer amp, it's a triangle, like an operational amplifier. The same for the low pass filter. And for the oscillator, I even use a crystal symbol for that. Here you have the LEDs as well. I gave them color. And another useful thing you can do is to add the functions of the MCU. Okay, so we have this. Go back to our worksheet. Now, step number 3. Step number 3 is making the connections between the different elements. For that, basically connecting, for example, the sensor connector to the buffer amplifier, and then buffer amplifier to the MCU, and so on. For the power sources, it can get quite hectic to connect every single device to the voltage regulator. To simplify that, you can add this T symbol with the label of the power supply to each device, and this way resembles the connection. For signals that have multiple wires, for example SPI, here there is an SPI connection between the MCU and the SD card. You don't really have to draw 4 wires. In here you can just draw one, because it does the job of representing the connection, which is the main objective of the block diagram. So after you finish step 3, your diagram should look like this. We have everything connected now. We even draw some ground symbols on some of the battery, some of the external connectors. Yeah, and everything is just connected together. And after that, an extra step that you can do that I haven't written on the worksheet is to add external elements. External elements, well, are not absolutely necessary because it's not actually part of your board, but they complement the whole system view, which is very useful to have it added on your block diagram. So let's add the external elements. This external elements will be, in this case, the sensors itself, a little hand here to show the user hitting the sensors, external amplifier, the on-off switch, the battery, 5 volts external supply to connect via USB, and even a little photo of a solar panel. So yeah, it just looks better and it gives a better overview of the whole product itself. So that concludes our video. I hope you have learned how to draft your block diagram. Until next time, if you have any questions, just you can write me to my email or leave anything in the comments, Facebook, anything. Thank you very much. Bye.